Good day, everyone, and I want to thank you for tuning in to a live technical webinar presented by the Northwest Energy Efficiency Council. The BOC offers live instructional webinars throughout the year to keep you informed about the dynamic field of building operations and maintenance. Be sure to save the next date or our next session, May 15th. It's titled Playing for Savings. And it's about how sports facilities are improving their operations and saving energy and cash and doing good. I want to thank the sponsors for today's webinar: San Diego Gas and Electric, Seattle City Light, Pacific Gas and Electric Company, Better Bricks, National Grid, Snohomish County Public Utility District, and the Puget Sound Energy. Today's session is titled Are You Solar PV Ready? With Kevin Schrapp presenting. Kevin is the division manager for the Northwest Wind and Solar Company. He is directly responsible for all business operations, projects, and customer satisfaction with a focus on design and installation management. With over 150 projects and a megawatt of solar PV deployed in Washington State, he is pleased to have established a diverse project portfolio and an extensive list of professional references. Kevin has previous experience managing custom home construction and community development, as well as commercial and industrial estimating and project management. Before we begin, I'd like to reference just a few housekeeping items. Information on how to access today's slides can be found in the email confirmation that you received when you registered. And I'm going to be sharing that slide with you in just a second with that link. And because we have a lot of people registered for this webinar, the phone lines will remain muted throughout the presentation to minimize background noise. We will have about 15 minutes for a question and answer session at the end of the presentation. If you have questions, just type them into the question block in the control panel of the GoToWebinar. And we'll queue those questions up and ask them of Kevin at the end. So the learning objectives for today's webinar are, hopefully by the end of today's webinar, you'll be able to name the basic system components and explain the functions and benefits of solar PV. You'll be able to discuss the general economics available from PV investment options, explain how to assess best locations for a PV installation, and discuss the basic considerations of PV ownership, maintenance, and monitoring of installed systems. Okay, so I am going to go ahead and turn it over to you, Kevin.
Okay, thank you. I too want to thank the Energy Efficiency Council, the sponsors, and all attendees for having me. I've committed my career to solar PV, so I'm always excited to have an audience and to talk about these systems and the many benefits. It's an exciting time for the solar PV industry. Like all technologies, as widespread adoption grows and as equipment prices go down, the types of investors grow, and the industry has seen some pretty rapid growth over the last 3 years as a result of all those things coming together to offer better economic investments. So let's go with the next slide. So Northwest Wind and Solar, my company, is a division of SME Inc. Seattle. They're an established electrical contractor that's been doing electrical services for over 40 years. I want to specifically point out that the presentation is about solar PV, which is solar electricity systems. These can sometimes be confused with solar thermal, solar hot water, passive solar type approaches with design. We're strictly talking about solar electricity here, and for the most part, the rectangular solar panel that I think most people are familiar with. We have in-house design and engineering services, and all of our installations are performed by licensed electricians. And that's a good point to make, being that these systems are electrically based. They are fairly hazardous when you're talking about electric generators on top of roofs or on frames. These are systems that should be designed and installed by only qualified and even certified professionals. So my background is in construction project management. I have a construction project management degree. I have been working with Northwest Wind and Solar since 2009, and my current duties are focused really from concept all the way to turnover to a customer. So ready for the next slide, please. Wanted to take some time to show some of our existing portfolio, just to give some real-world examples of projects that we've been involved with and that are installed in Washington State. The Bullitt Center is a really great example. It's one of our flagship projects, and if you're not familiar with the Bullitt Center, I highly recommend doing a search on that project. It is considered the greenest commercial building in the world, located in Seattle, Washington. The project has many different environmentally friendly and sustainability attributes, but on top of the building is a solar array that produces as much electricity as the 6-story commercial building will consume in 1 calendar year. And a really fascinating point to make about that building is that it's located in Seattle, which has a climate that most people don't consider to be a very good solar resource. And I think the testament here is that solar can produce enough electricity for a 6-story high-rise in Seattle. It really is an effective energy source. Next slide, please. Here we're looking at the Seattle Aquarium. This system is what I consider a flush mount installation, which follows the roof line. This type of installation is the most cost effective, and I consider it the standard installation detail. If there's a sloped roof facing south or facing a good solar exposure, installing in plane with the roof has many benefits, and it is the most cost effective way to apply solar. Next slide, please. Here's another net zero energy project, which means the solar array produces as much electricity as those facilities will use in 1 calendar year. Different from the Bullitt Center, this one is a multifamily townhome complex. It's actually 10 individual units. Each unit has its own independent solar array on the roof. So each one of those units has a custom designed solar array to produce as much electricity as the engineering consultants forecasted would be used. A good point to make with new construction is that designing a net zero energy approach, it does depend on a good load estimate. And really load on an annual basis depends on the user. And so if you got an irresponsible user that's leaving the lights on, or that is not making energy efficient choices, their need may be much greater than another type of consumer. But in order to try to make these designs, you use the best design capabilities available, and we've actually, all of those units have exceeded the expectations, and they're actually producing more electricity than the facilities need. So we're definitely meeting the goals on those projects. Next slide, please. Here's a quick shot at some residential applications. Again, most in these pictures are flush in plane with the roof line. The one on the far right is a flat roof type installation, and we'll cover that in detail when we look at some commercial applications, and further on in the presentation I'll really talk about design concepts. But this gives you a general idea what an array might look like on a residence. Let's go to the next slide. And here's a collection of commercial examples. These are all projects we designed and installed. As you can see, they vary quite a bit. Well, to me they vary quite a bit, but the application is different. Whether you've got a flat roof, a slope type roof, there's ways to install vertically, like the school on the top right, where it looks like a shade awning, and really understanding the facility is part of what goes into making a really good solar design. Solar is just like any type of construction. Anything can be built, but really, when you're talking about solar, most consumers are doing it because they want to realize a good investment, and so installing it in the most cost-effective and optimal way to produce the most electricity is a goal that all solar designers are working towards. And a facility owner, hopefully by the end of our presentation, will be able to identify, generally where those locations might be on their facilities or properties, and be able to understand how these different types of installations would apply best to their circumstances. Let's go to the next slide. Okay, so PV 101, how does solar electricity work? This diagram is very simple, so it's a great diagram for someone who may not be familiar at all with electrical systems and with PV. And I'm going to kind of walk through these icons 1 through 5 just to explain really how a grid-connected solar electric system works. And I mentioned grid-connected there, and you'll see number 5, they've got the power pole. That means this facility has got utility-powered electricity. So we're not talking about an off-grid cabin or getting off the grid in this example. Number 1 is your generator. So for this presentation, that's a photovoltaic solar array. And we use the term PV all the time. That stands for photovoltaic, and that is solar electricity. The solar electric panel produces electricity when the sun is out. It's difficult for a customer to really understand how a solar panel translates into energy, and it's not as simple as one panel on a roof produces this much energy. It's dependent upon their exposure to the sun, the location, the orientation, all things we'll talk about in the design criteria section. But your solar generator on the roof will produce electricity when it's exposed to sunlight, so it's only producing during the day. Number 2 is what we'll define as an inverter, and I'll talk in detail about the inverter. Inverter is kind of the brains of the entire system. That inverter is selected for the size of the solar array that it's going to be powering, and also the utility voltage that the facility is operating on. Most homes are at 240. Commercial buildings are 208 or 277, 480. Your inverter needs to be compatible with that voltage. What the inverter does is it converts the direct current DC power produced by the solar array. That DC power is similar to the power in a car battery. It's direct current, just a positive and a negative. The inverter converts it to alternating current, AC. All homes and facilities function on alternating current AC power. So that inverter converts the solar energy into usable AC power. It synchronizes with the utility grid, and that inverter actually has an ability to communicate with the utility grid, and in event of a power outage, that inverter is going to shut down. The United States has a safety function that requires all inverters to have a thing called UL 1741, which shuts down in event of a power outage. If there's no utility power, it shuts down so that you're not backfeeding power onto a disabled power line and exposing service workers trying to repair a problem to electricity. And so that's an anti-islanding function. The inverter sends alternating current to number 3. Number 3 is your electrical house panel. So in a commercial facility, you'll have a main distribution panels and a series of sub-panels throughout the building. You can connect it to a sub-panel or a main distribution panel as long as it's electrically rated to receive that much solar backfed, and that's all dependent on NEC calculations. I'm not going to get too far into those details, but the electricity is fed directly into that house panel, and if there's loads, meaning if there's lights on, if the TV is on, if people are working from computers, number 3 is going to use the solar electricity first because the inverter has an ability to make its electricity more dominant than the utility grid. It ramps up the frequency of that electricity. So every kilowatt hour produced during the day, you're going to use instantly on number 4. And so what that means is every kilowatt hour produced by that solar array, you don't have to buy from the utility. So you're getting the benefit of that electricity. And when you don't have to buy that, it means you get the actual retail rate of that electricity. If you have a tiered rate schedule where your utility charges you more during the day, having a solar array on your roof, it's providing electricity at that highest rate. If, for example, you're producing more electricity than you can consume at any given time, like some of the net zero energy examples I provided, like the Bullitt Center and the Z-Home Townhome complex, excess production that you produce that you cannot consume at number 4 is then sent out to the utility grid. And this is where customers often refer to as selling power back to your utility. A better way of describing that is you're actually getting credits. So in between 3 and 5, there's going to be a service meter, which when you install a solar array, it becomes a net meter. That meter is bidirectional. So every kilowatt hour you produce will actually spin your meter back that you produce and don't use. It will spin your meter backwards, in essence giving you a credit, and that power will go out to the utility grid and they'll sell it to the nearest neighbor, going through their utility meter and charging the customer for it. But you got that credit. So customers use those credits up at night and into winter if they have excess in the summer. Next slide, please. So some of the parts that I just talked about, solar panels, what you're looking at there is a aluminum frame solar panel. That is considered a rigid solar panel. That is really the most common type of product. We'll talk about some other solar types of options, but solar, it's really been around since the 70s. NASA initially introduced photovoltaic modules for powering satellites, and this is not a new technology. It is something that's been around for a long time, and there's a lot to be said for this being a tried and true product and technology that's been around for a long time. It's bankable. It has actually been around long enough that manufacturers have been able to scale and grow their company to really drive those costs down. So a lot of questions come to me about new products, about thin films, about solar shingles, about solar paint. Those things are all great and things to keep an eye on, but I consider those more research and development type of products that are really expensive and that, in some cases haven't really kept up with the continuous improvement of this original tried and true product. So from a cost standpoint, the cost for this standard on-the-shelf product that's readily available is much, much lower than some of these new products that are introduced and that are still kind of in a research and development stage. They haven't achieved the main or the widespread adoption. The image in the upper right, you see the small kind of bluish purple rectangle. That's an example of a set of inverters. And then on the image down below, we've got the large white box is an example of a large commercial inverter. And then, of course, you see disconnects and meter stacks over to the left with the solar arrays in the background. So next slide, please. Here's an example electrical diagram. For most customers, you know, your engineering type customers and facility operators would be interested to see this, but it's just kind of for demonstration purposes. Shows inverters, shows your disconnect, shows your meter, and an interconnection to the house panel on that far left with the meter. So this is just kind of an electrical illustration of my first PV 101 diagram. So let's jump to the next slide. All right, so on to federal and state incentives. The solar PV, it does rely on federal and state subsidies. It cannot stand alone and compete with current fossil fuel sources of energy or even hydroelectric power that we have up here in the Northwest. You know, and a good point would be made that a lot of those sources are also subsidized. But federal and state governments recognize the benefit of these solar PV type systems and small renewable generators. They recognize that distributed generation, meaning having the generation source on top of a building at the point of use, offers the federal and state governments long-term benefit where infrastructure for utilities can be minimized. And when looking at this from a global perspective, you know, population growth is going to continue. Where are these new sources of energy going to come from? You know, the cost to put in a new nuclear reactor or the cost to put in a new hydroelectric dam, it's a significant expense. And so by offering consumers subsidies to purchase these systems, it's a way to keep up with population growth in an environmentally friendly way. And so that's my quick way of explaining and justifying why these incentives exist. The first major incentive is the 30% federal income tax credit. That's currently good until 2016. That is good for any federal taxpayer. If you purchase the system, that entire contract amount for that array and the electrical installation, you can receive a 30% income tax credit. If you don't have a tax appetite large enough to take that entire 30% in 1 year, it can be rolled from year to year. A very common question is, you know, how do you define the system cost? Because oftentimes there's roofing costs included. Occasionally there's structural requirements included. And they have actually identified that roofing directly beneath solar arrays can also take the income tax credit. Structural requirements for the solar can also take the credit. But if you had a large roof and you put solar on the south side, you would not be able to take it for the roof area on the north side. The second one is accelerated bonus depreciation. That is currently a year-to-year program. The feds have, it's been a year-to-year program for the last 4 years, and they have continued to extend it. It's something that I hope continues to be extended into the future. But right now, it's a 5-year bonus accelerated depreciation. You can take 50% in the first year and the rest in the remaining 5 years. RECs, or renewable energy credits, it's something I'm not an expert in. The Northwest doesn't really have a market for those. But to explain what they are, it's a megawatt hour of renewable clean electricity. And there are some markets for it, I believe, on the East Coast and other places in the world where, you know, people who have a large carbon footprint will purchase renewable energy credits to be able to offset, you know, their pollution or their carbon footprint, and there's value for those. But again, you know, I can't speak to those directly. I don't have experience with them here in our market. There's not really one. I do hope that down the road it's something that becomes more of a universal value. Next line item, please. In Washington, we have a thing called a production incentive, and you can actually extend all those out. And this is a state-specific incentive. I won't get too far into the details on how this works because I understand there's a national audience, but it is good to know your state incentive program. Oftentimes it makes a big difference. And in our state, it's up to $5,000 a year. And for a residential customer, that incentive can get you, a 5-year return on your investment. In Washington, this is geared towards smaller systems, so it doesn't make as big of an impact on commercial type projects. But every state may be a little different. If your state doesn't have any incentives, that would be a harder economic sale. But at the same time, looking at utility electrical costs has a big influence as well. We have really cheap electricity in the Northwest, so if electricity were more expensive, maybe that subsidy wouldn't even be needed. Sales tax exemptions are common, and also utilities have various rebates. And again, the federal and state governments and even utilities recognize the benefits of these systems, and so they're subsidizing customers to make the investment to contribute towards more deployment. Next slide. So how do you purchase a system? The biggest hurdle is always upfront cost. If you just ask anybody on the street, are you interested in solar? I think just about everybody would say yes. If you ask a customer, if they would want solar, everybody will say yes, but it really comes down to, are you willing to pay for it? And upfront cost, it continues to be the biggest hurdle, but there are ways to, make that less of a capital investment upfront. And so I'm just going to kind of go through the pros and cons of the various options, and there definitely are pros and cons to each. And really understanding the purchase options, just like when buying a car, it really might favor a different type of customer with a different type of investment. And so really knowing your options is best, and any responsible or qualified installer should be able to speak to all these options in detail for your specific market. So a cash purchase, again, the pro there is that it's your best long-term investment. You're owning that system, you're owning that equipment. Once you've able to achieve a return on investment, that's free electricity for the life of the system. Most solar arrays, they have a 30 to 40-year system life. I'll talk about that in more detail at the end in our operation and maintenance section. But by owning that equipment and paying it off, you're not paying interest, you're not giving up any of the incentives or subsidies, and so over the life of the system, you're able to save the most amount of money. The con is the upfront cost. You actually have to pay for the system, and you own the system, so you could be responsible for maintenance, which is maintenance is not significant, and lots of installers offer service and maintenance packages as well, but you would be responsible for it. So the second option is finance. You can make a down payment and make monthly payments. The con there is that you are paying interest. There are limits to financing. There's currently no commercial financing available in Washington. I know that there is in California, there is in New Jersey, but understanding which markets have those financing options is great. We do have a lot of local residential financing options, really low percentages where they just take a lien on the equipment, and it rates, in the mid 4.5%, and out to 15 years. So for a resident, you can make a fairly small monthly payment, sometimes comparable to your electric bill, and own the system outright after 10 or 15 years. The lease or the power purchase agreement is something that has gained a lot of traction in markets where it is allowed. The benefit for this program, well, let me first explain what it is. A lease is where a third party, a company, actually owns the equipment, and they offer it to a building host as a lease. So if you own your own facility, you would be signing a lease agreement with a company who owns the solar array, and the lease, there's negotiated terms, but they're going to sell you electricity for slightly less than what you're paying your utility. The reason customers do that is because it's easy. In some cases, there's no upfront cost. they'll put the equipment on your roof, they'll maintain it for 10 years, and you get cheaper electricity. The con there is that over the life of the system, you know, what you would have paid in those electrical rates, you could have most likely went and bought that system outright, sometimes a couple times over. And so you're not getting the full value, but it's really good if you're looking at a lease or power purchase agreement to really look at the details, weigh your options, and really understand what type of investment you're trying to make. A lot of big box stores and chain retailers, they love the power purchase agreement because they don't want to have any liability, any maintenance. It's a way for them to save money and to go green, so it makes perfect sense for them. Next slide, please. So here's a cash flow example showing how all those incentives come together and the net metering. You know, this slide's going to be available to you, so I'm not going to spend too much time going through it. But starting at the top, you're looking at a 35 kilowatt system. The total installed cost is about $110,000. That's you know, that's market rate right now for a turnkey installation on an existing building. You've got sales tax directly below that, which reduces your contract cost or increases your contract cost, sorry. And then down below, there's a Washington State sales tax refund, which in our state it's 75% for large systems, commercial systems. You're looking at your 30% tax credit there at $33,000. And so your net system cost, if you can take the full tax credit after the first year, is $78,000. Looking down below at the before tax cash flows, you see those figures. Net metering, net metering is the electricity savings. This net metering here is at 10 cents a kilowatt hour. That's Washington's rate, which is, again, pretty cheap. And it does assume a 5% inflation. So that's something that if you're going to forecast a solar investment over the life of the system, you have to have some type of speculated rate increase. And 5% is a national and local conservative estimate. We've seen inflation rates of 7 and sometimes 10% year after year. So that's a conservative estimate. But you're seeing the value of the produced electricity there year over year. And then we've got a local production incentive, which you're seeing the benefit there. This goes years 1 through 10, and then it skips 10 years to 20, 30, and year 40. Down below, the next section is the after-tax effect. So you get to see what the depreciation benefit is. And in this example, you're getting your money back in year 5. You're looking at a discount rate of 15%, and your after-tax net present value is about $18,000, and after-tax IRR is about 19%. So for you financial folks, you know, that's considered a fairly sound investment. The last point I want to make is all the way out there on the bottom right. Over the life of the system, you know, a customer is positive $450 grand in electricity savings. So next slide, please. Moving into the design criteria. This is where I'm going to get into some of the details about why you would install solar panels a certain way on your building. This first diagram really reflects that you have to understand how the sun travels across the horizon. These panels produce electricity when exposed to sunlight. If it's cloudy or rainy, they produce less. If there's shade, they produce less. If you have a big mountain to the east and the sun doesn't break that mountain till later in the day, you're not going to produce as much electricity as you would if you had, you know, completely open access to the sun year-round. So understanding your location is important to be able to estimate what a solar panel is going to produce. Because we're in the northern hemisphere, the sun is you know, to the south for most of the year. It's lower in the sky in the winter, higher in the sky in the summer. So when you're setting solar panels on a roof, knowing which orientation and being able to make recommendations that optimize production is key. So for panel tilt, the optimal tilt, or I'm sorry, let's go back to east or west. Due south is typically best. That's where you're going to get the sun highest in the sky and the panel's perpendicular with the sun for the longest amount of time. East or west, you can typically expect about a 10 to 15% reduction. So southeast, southwest, not deal breakers at all. We put panels southeast and southwest all the time. In terms of tilt, the best tilt for northern locations like Washington, we're at 47 degrees latitude. They say latitude minus 15. So about 30 to 35 degree tilt produces the most due south. For southern locations, a shallower tilt's gonna do a little better because the sun's higher in the sky more times throughout the year. In terms of cost, structural loading, and power density, putting panels in plane with the roof is the way to put one panel after another and really put as much solar in one area as possible. Looking at the example at the bottom left, that project, the architect, the concept and approach was to have the array be highly visible. The downside there is that the loading on the back of that tilted up array is significant. So the structural requirements were very high. Wind blowing at the back of that solar array is the controlling structural load. They actually need to put large structural beams to accommodate the loading on that. A more cost-effective way to install is like the far right picture. Single rows on a low profile, spaced out far enough so that one row doesn't shade the one behind it. That's how you can get the structural loading down as much as possible so you don't need a really strong roof. That picture is also a ballast type installation, which means that ballast blocks weight the array down to the roof and it distributes the load over the entire roof. The benefits there are minimal structural penetration through the roof, fewer thermal breaks, which keeps your R value preserved in that roof, and the ballast distributed across the roof system instead of requiring structural attachments, which involves a lot of coordination. Next slide, please. So again, ballast installations offer about a 4 to 8 pounds per square foot. They're non-penetrating. Attached type installations are a little more complicated to execute on a flat roof. You actually need structure to accommodate these panels. They, like I said, the wind controlling factor is large. You need to make sure they're not going to blow off and that they're actually attached and that your roof is rated to accommodate that loading. And so if you can ballast an array, that's the most cost-effective way to do it. And when you're trying to get good economics, a cost-effective installation is crucial. So next slide, please. Here we're looking at some sloped roof attachment details. On the left, you've got a flashed shingle. We've installed thousands and thousands of those assemblies, and they're designed to be retrofitted into a composite type shingle. So the flashing actually goes through the upper course. A lag bolt is elevated. You can see in the detail that there's an elevated area where a lag bolt penetrates through that frame, secures a bracket, and it's gasketed with a cap over the top. There's really no way for water to get through. A standing seam metal roof it's really a great detail. There's no penetration there at all. That clamp can attach directly to the seam, and so there's no penetrations. So for commercial projects with standing seams, looking at a vertical seam that accommodates that type of attachment is a good approach if you can make that decision. They do make clamps that accommodate almost all profiles. The far right picture is an example of a tilted array like some of the examples I talked about earlier. Those standoffs need to attach to structure, which means that you have to have a roof structure laid out in a grid that accommodates, your solar array frame. And a lot of times, if the roof wasn't planned for that, it may not work, which is why ballast is always a better way to go on a flat roof if that is a coordination issue. Next slide. So here's another shot at those commercial projects. Just kind of for a rule of thumb, for every kilowatt, you need about 100 square feet. And that clearly may vary depending on whether you have a ballast installation or a tilted installation, and it has a lot to do with which type of solar panel you use. But a real general rule of thumb is about 100 square feet per installed kilowatt. Just for a reference, residences, to offset an entire home, and I need to point out that every home is different. You've got different types of appliances, different use patterns, but the average home needs about 10 to say 20 kilowatts to offset the entire annual load. Commercial businesses are so drastically different. A lot of them have large, equipment loads, and it's really difficult to try to use a rule of thumb there, but hopefully my residential example helps put some perspective on about how much solar you need. And again, the Bullitt Center can be used to show a best case scenario commercial type complete offset. Most customers are investing based on a budget figure they have in mind for solar or how much optimal roof space they have. Trying to go net zero is not, that's kind of the person going for the badge of honor. A majority of consumers, they're completely happy with a 50% offset or whatever their budget or roof will allow. There are different types of inverters. String inverters are kind of the standard. That's the most cost-effective way to go. The pictures on the left illustrate string inverters. Those inverters are sized in groups to connect with a solar array up on the roof. The large commercial example over on the right is a commercial central inverter. The con for a central inverter is that you need floor space for it, so it takes up a lot more space and real estate. Also, you need that inverter has to connect with all those solar panels facing the exact same direction, so it's less modular, and you need to have a completely large, wide open, consistent space to utilize a central inverter. Another negative to a central inverter is that it's a single point of failure. If that central inverter goes down, your entire array is down instead of one inverter. So next slide. So if there is some partial shading, which shading is not good for solar, it shuts the solar panel down, and string inverters electrically, if one panel is shaded, it actually affects the entire string. And so if you do have some shading, there's some electrical ways to combat that. Next slide, please. And a microinverter is a way to attach an inverter to every single panel. The benefit there is that if you have shading, it doesn't affect the entire string. You have independent functioning modules and inverters, so you get the full production out of every single one. The negative there is that you do have an electrical point of failure on every single panel, and microinverters add about a 10 to 15% cost increase over a string or central inverter. Next slide. So racking is the actual frames, and solar panels themselves are not structural. They need a frame to attach them to a roof structure. And here's an example. The left are some rails. You see the standing seam example to the right, and then on the bottom right is a cut of a ballast type application. Racking is kind of the most underestimated part of solar installation, and choosing the right racking, it's where the real value is, and to really optimize the system and do it in the best way. Let's do the next slide. So I've been primarily focusing on roofs. The reason being, a roof has an existing structure. In most cases, from my perspective, roofs are fairly unused. They're there to protect and weatherize. If you can install solar panels on a roof and aesthetics, are not an issue for your customer or your community, utilizing roof space is always the best way to go, or the most cost-effective way. Parking structures are another great application. If you're strictly looking at your parking structure investment from a solar standpoint, you have the added structural cost in building those frames, doing the underground foundations, all those additional provisions which may, they'll have, a significant impact on your return and your payback. So you have to really look at it from a dual purpose standpoint. You're offering a shade structure and there's solar on top. Ground mount is most common for utility scale type applications. They're not all that common for commercial or private business owners. The added cost in the ground mount is, of course, you're taking up real estate. You've got underground trenching, foundations, feeders, all the way back to wherever your electrical service is. And so those costs in most cases are not justifiable for filling up a bunch of ground real estate for solar. It's really a utility scale thing where there's a community or a jurisdiction considers their land relatively unused and the impact, maybe relatively small. But ground mounts are not something that are really in my market. And then building integrated, of course, is a real, it's increasing in interest, trying to use multi-purposes in, a shade awning, a picnic area, even, an outdoor seating area with transparent glass. Those are all options. But again, doing that, there's extra provisions to try to execute a project like that. Next slide. So how do you know what your system will produce? The left image is a Solmetric Suneye. That is a device that can actually take an image of your roof. It will pick up trees, it'll pick up buildings, mountains, and you program in your location, you program in, the orientation and tilt of your solar array, and it will give you a solar access percentage that you can then plug into a program like PV Watts. PV Watts, you can look up online, version 1. It's put out by NREL, the National Renewable Energy Lab, and that program takes 30-year solar data from locations throughout the world, and if you plug in, your data points that you would get from a Solmetric and from your system design, you can estimate how much production you're going to see on a month-by-month basis. And so, having a tool like that is a way for you to really provide a customer with a tangible report that, justifies what the system will produce, and, you're not just taking somebody's word for it. And using a third party, a reputable source is good. There's dozens of estimating tools. I like to stick with NREL because it's most recognized by our local utilities. Next slide. So operation and maintenance. I talked about solar being relatively easy to maintain, and that is true. Think of it as another electrical system. You don't question, how long your wiring and your conduit and your light fixtures will last. Solar is electrical. It's made with exterior rated materials, glass, anodized aluminum, and when installed with the correct stainless steel hardware, really nothing should break down or wear out. The solar panel itself does derate over time, and what that means is that over time it loses its production efficiency, and it is a way where it wears out over time, but it's a very small amount. Most reputable solar manufacturers guarantee their panel to produce 80% of the rated capacity after 25 years. So the fact that they have a 25-year power warranty tells you that, this panel is going to last for 30 years, maybe 40 years. D-rate has a lot to do with the site and the environment. Up in Washington, we got a pretty temperate climate, so the D-rate's pretty small. If you're down somewhere like Arizona where you have very extreme temperature swings, that D-rate's a little bit more. The one point of maintenance that is necessary is cleaning. You want to keep those modules clean. If you've got a 10-degree tilt, minimum, rain in most cases has a self-cleaning effect. But as you can see in the image there, a gentleman there is using a squeegee to clean those panels. If you are in Arizona and you've got a lot of dust storms, that maintenance may be more of an issue than if you're somewhere where it rains a lot. From a roofing standpoint, customers always ask about re-roofing, and I like to say that, don't put solar over a roof that's expired or that needs to be replaced soon. Install a new roof and put solar over it so that you've got comparable warranties in place. Solar panels actually protect the roof underneath it. They're not exposed to UV or the elements, and so the life of that roof is actually extended. But if you did find an instance where a solar array got put on a roof that had issues and you needed to re-roof, they can be disassembled the same way they're installed. But that is a considerable, expense for that much labor to take it all apart, stockpile it, put it back together. I always, recommend to install arrays on a roof that's got plenty of roof life left. Warranties, I mentioned the panels. Inverters have a 10-year warranty, so that's kind of the one point of failure that needs a replacement. Inverters are a small percentage of the cost, but figure a inverter replacement over the life of the system at about the 12 or 15-year mark. You can buy extended warranties, or the racking systems typically have 10-year warranties, and if you have good wire management and stainless steel hardware, the system's going to last the life expectancy of the panel for those 30, 40 years. So monitoring is something that's available. Online monitoring is great. Almost all inverters have communication ability, and if you've got a large array, most customers are very excited about their system. They want to be able to watch and see what the system's producing, and so spending a little bit extra on a monitoring package is a wise investment. In most cases, if it's a web-enabled monitoring package, you can log in from any web-enabled device, smartphone, tablet, and you can see what your system's doing on an instantaneous basis. And you can data log from year to year and month to month, and it also gives you alerts as an installer. Those services are great because if there's an inverter fault or if there's an issue, it sends us a notice, and oftentimes your installer notifies you of an issue with your array before you do, and they're repairing it under warranty in advance if they've got good customer service ability. One other roofing consideration is for a ballast type system, check with your roofing manufacturer. They may require roofing pads instead of just putting it right on top of the membrane. Some manufacturers want a superficial membrane over the top, which is a point of expense. And then, of course, most installers are not licensed roofers, so hiring a roof expert that is licensed and certified to warranty that product for any penetrations you do make is a really, really wise decision. So for the sake of time, I'm thinking I should probably wrap it up and field some questions. And thank you very much for your attention. And that was a lot of information to cover. So I really appreciate this opportunity.
Thanks so much, Kevin. We'll go ahead and open up the floor here to questions. And we do have a few questions already queued up, so we'll go ahead and start taking those. But if you have not yet submitted your question, just feel free to type that into the question block in the GoToWebinar control panel on your screen. So Kevin, one question that we have here is related to special variances that may be required in installing a PV array. One comes to mind is that the example of the Bullitt Center that you spoke about at the beginning of your presentation. This particular building had to have a special code variance. Do you find that and that had to do with the overhang to get enough solar onto the roof? Do you find that is a fairly common issue?
Yeah, I would say that in the case of the Bullitt Foundation building, that was a unique circumstance. Most customers are not building a cantilever out over setbacks or even their sidewalks. The Bullitt Center's approach was to install an array that provided their entire load, and to do that, they needed more roof square footage than the building would provide. that's why that design kind of looks like a graduation cap and why they need those overhangs. So, you know, it was unique, but working with the city, you know, just like in doing any type of construction, if you've got all your plans, engineering, and your permit application in place and submitted correctly, you know, the city will review it, look at it from a land use perspective, see if there's going to be any impact to the neighbors' views or the environment, and they'll make a decision whether they'll approve that or not if it's outside the standard building code. So that overhang, it was unique, but you know, it's something that can be approved with proper permitting. A variance that is very common is a metering variance through the utility, and the utility requires a meter to be installed, typically a solar meter installed right next to your service meter, and oftentimes electrically that's challenging. And so a utility will allow you to put a meter out on an outbuilding or right next to the solar array, opposed to trying to trench underground or all the way out to a street where your service meter might be.
Okay, thanks for that explanation. We have a couple of questions related to your slide on incentives. We have a couple of participants just wanting clarification on programs. Were you saying that in Washington State there is a sales tax exemption for solar PV?
There is, yes. For systems under 10 kilowatts, there's 100% sales tax exemption. For systems over 10 kilowatts, it is a 75% sales tax rebate. So for systems over 10, you have to pay the sales tax up front, but then you apply for a rebate and they'll refund you 75%. You do have to pay 10% of that sales tax.
Okay, and are you familiar at all with the community solar it's a project in Washington State. It's a cooperative project that deals with delivery methods. Do you know anything about
I don't know about delivery methods, but I'm very familiar with community solar in Washington State. The production incentive I talked about has a provision where they pay the highest rate for community type projects. And the Seattle Aquarium, the second slide I showed, was a community solar project. Mm-hmm. Those are fairly difficult to execute from a legal standpoint because they involve investors. And when you're talking about state incentives and investors, the legal requirements in constructing a model like that are very involved. And so a lot of firms, there were firms early on in Washington that really just set up to try to be community solar developers, and a lot of them weren't successful doing so. Most of the community solar projects are owned by utilities who are able to waive a lot of the private legalities and red tape that have held some of those projects up.
Okay, thanks. And can you just speak a little bit about, or maybe just refresh our memory regarding the kind of like the rule of thumb for estimating the cost per kilowatt needed?
Oh yeah, so cost is something I didn't really touch on, but I'm glad you brought that up. You know, the cost is completely dependent on size. The larger a system you do, the cheaper it is typically, because you know you've got a lot of you know, upfront costs just to do any project, like permitting, like project management, mobilization to and from the site, and electrical work. To do more solar, you can obviously achieve economies of scale and do it cheaper. And so, you know, a general budget for a mid-sized commercial project's, you know, $3 to $3.50 a watt, and that is pretty remarkable compared to 2 years ago. I think a lot of things were published in the $4 to $5 range. So, you know, the price has come down, you know, a third to half over the last 3 to 4 years. Residential small systems are typically more per watt because, again, they're smaller and you don't get that scale. But still, anywhere from the $3.50 to $4.50 a watt is very common for residential systems. And, you know, the average residential system right now that I'm aware of is about 5 to 6 kilowatts, and that's in the $20,000 range. Commercial systems are completely across the board. It varies greatly, I think, from state to state.
Okay. And can you maybe provide a little bit of information on accelerated depreciation and whether local governments qualify? Do you have any experience with that, or where more information can be gathered on that topic?
Yeah, I think I'll defer to where more information can be gathered. I'm not really a tax advisor. I usually, I do speak in general terms, so I understand the program, but everybody's tax situation is different, and so it's really good to consult with your own tax professional. But there's a website called Desire, DSIRE, and that's the database of state and federal renewable incentives, and that is an excellent site to check out. It lists out all the federal incentives, the 30% income tax credit, accelerated depreciation, lists the entire program out, and then you can drill in from state to state to see what incentives might be available to you locally.
Okay, excellent. Thank you. And then just one other question, and when we have time for here, and what concerns do snow or snow melting? Does snow melt off the panels easily, or are there any special considerations for maintenance of panels during a snowstorm, or do the panels give off heat, for example?
Yeah, no, great question. And panels do give off heat. They are electrical devices, and a misconception is that cold panels actually produce more power than hot ones. Just like all electronics, your computer and your and various things have fans to cool the electronics. Very cold, actually, you design a solar array based on a thing called open circuit condition, which is the record cold temperature with a crystal clear sunny day. That's when that system's going to produce the most power. And so from a snow standpoint, if you are in an area with lots of snow, you got to be concerned with ice damming. And people that install, roofing are very familiar with details to avoid that. And what I'm talking about is the panels themselves are elevated up off the roof, hopefully a minimum of 4 inches to allow air to circulate and cool them off for that higher efficiency. But that 4-inch difference on the top edge of an array can collect snow. And if you've got snow on those panels and sun filters through, it'll warm up and that snow will slough off. I've seen when we do get snow in our area, the solar array, the rest of the roof has snow, but the solar array doesn't because it heats up and the snow sloughs off right away. But on the top side, if you have enough snow, you can get an ice buildup right there where water can actually, be forced upwards, which is a bad deal. So you never want to have a solar array over the top of a ridge if it's a place with lots of snow. And from a maintenance standpoint, if you get tons and tons of snow, you probably want to have access to a roof to be able to shovel those panels off, because if you had 4 feet of snow on top of them, no sun's ever going to get through them to be able to melt it off, and it would just stay there all winter long.
Okay, great. Well, thank you so much for the presentation and for clarifying these questions for us. This wraps up our today's session. I hope this presentation on solar PV provided you practical information on PV systems, installation, maintenance, and investment considerations for anyone who is interested in delving deeper into the topic of energy efficiency in commercial buildings and best practices in energy management, operations and maintenance, demand reduction, lighting, indoor air quality. You are most welcome to join a BOC in-class experience, and it's always led by industry experts in commercial building systems and technologies. If you desire more information on the BOC, you can visit our website, learn about classes in your area. They're administered nationally by our network of implementation partners listed here. I also want to remind those of you who already hold the BOC credential, the BOC graduate, successful completion of this webinar and the accompanying quiz provides 1.5 points towards maintaining your BOC credential. And to earn the points, just take the quiz at the link that was provided to you in the email confirmation notice you received and submit information to us with your renewal application. Thank you, Kevin Shabbat, for a very informational and interesting and well-organized presentation. And thanks to you all who participated today. This concludes today's webinar.
All right, thank you.